Our first talk today is going to be by Jakob Povšič, who's the software architect at Global ID, and he's going to speak to us about self-sovereign identities.
So yeah, I'll be speaking about self-sovereign identity. So let's just write off what is self-sovereign identity. So SSI, in short, self-sovereign identity is primarily this new approach to digital identities, where instead of other companies owning your data, the user is in complete control over their identity and all the data that's associated with that identity and exists outside any centralized authority. So, but in a broader context, it's not just, at least to me, it's not specifically something that applies only to digital identities, but can be more broadly appreciated as more of a philosophy in thinking about like information and ownership of that information and its authenticity. So I'll expand on that a bit more. But before we go into how SSI solves or works, let's first define what is the actual problem it's solving. So in the current identity model, identities and their data, associated data, your data, is not owned by the users themselves, but rather exists in silos, in silos controlled by other companies, institutions, and different legal entities, and the user only interfaces with these silos through some, authentication mechanism. But ultimately, it's, the model is as it's, shown on this picture, where your data exists somewhere else. So there are obvious, dangers and risks with this model that, manifest as, let's say, data leaks, where, your data is stolen by some hacker and then sold around. There's lots of documented cases where your data is, being sold or leveraged for some, political or commercial agenda, as was, for example, documented with, Cambridge Analytica case. These entities can also act as censors, causing you to lose access to your identity and the data that's associated with it. And this can be especially damaging today because certain platforms, are at a point where they're more akin to digital infrastructure, digital societal infrastructure, rather than just some non-essential system that you're voluntarily interacting with. So losing access to that can be really damaging to any individual. So, but more broadly speaking, so I'll go on a tiny tangent here. Like, while SSI is focusing on identities primarily, the tools that are being developed to solve this issue, at least in my opinion, have a much broader can have a much broader social impact, as fundamentally online, like the trust doesn't really exist. So this component of trust isn't really something that was ever thought about when designing, any kind of information networks. So, and today, as we're migrating more and more of, systems that exist within our society, where we're digitalizing more and more of our lives, lack of this trust as it exists online is becoming really kind of dangerous to our societies. So we are solving this locally, but we're solving it in a minimal way that just satisfies, let's say, some requirements by some small system, but it's not something that's broadly applied to the internet as a whole. So how does this manifest, in online spaces? So, criminals are very good at abusing this lack of trust in, for example, social media or on the internet in general, and millions of users are being defrauded every year because of this lack of trust component on the internet. And this is so common. It's happening everyone pretty much in plain sight that we become so desensitized to it. If you've ever used social media, there are tons of examples of people that are obviously, that obviously have some financial incentive in giving you some information or abusing some trust that you perceived from them. But these are only kind of very obvious violations of trust on the internet. So there's also other places where this lack of trust manifests, and one prominent example is obviously political misinformation. So this is probably documented well throughout each election cycle. Even more prevalent today is health misinformation. So just looking around, there's countless examples of misinformation being spread that results from like fake studies, fake claims from some supposed authorities within health. One other place where this manifests is, for example, capital markets. So in capital markets, generally, like asset prices are reflective of available information. And since social media, for example, is used to propagate news events and information, there are entities that have learned to leverage those platforms to manipulate the market, basically. And this has been studied and researched widely. For example, the effect of fake news on asset prices. So, for example, just 9 days ago, somebody posted a fake article about a partnership between Litecoin and Walmart, which sent the coin up, like it sent the price up for 25%. And this was just one of the milder cases. So there's document cases which were much more which caused much bigger changes in value. Another issue is, for example, consumer sentiment. So there's a wide proliferation of fake reviews online. So to the degree where, let's say, some platforms are very much unreliable for identifying quality. For example, I have this problem in Google Maps where I cannot, it's difficult to find, let's say, a good place to eat. The most useful component, let's say, of Google Maps to identify places is when looking at what to avoid. So, but yeah, not necessarily saying that Google Maps is, or that restaurants are paying for fake reviews, just that places where it's difficult to verify whether some statement is authentic or not, are bound to have very inaccurate quality estimations. But yeah, so here is one Hall of Fame example. So back in March, when Amazon was holding a vote whether to form a union for workers, Amazon was caught creating fake Twitter accounts that used to spread like this sentiment that unions are not desired and something that's something that people do not want, or the employers do not want. So, but this was a pretty sloppy event, a pretty sloppy attempt from Amazon. So they were caught and called out on it, and these accounts were banned. But this is a sloppy example. So there are many others which are much more sophisticated and indistinguishable from real users that are used to that are very influential in many aspects of digital life. So I said this was a bit of a tangent, as I just wanted to kind of highlight what are the broader social problems that arise from the lack of trust online. And potentially these tools that are being developed through SSI could have could improve some of these experiences. Not necessarily they would ultimately solve them, but they would give us a tool where we could have a less horrible experience in this regard. So yeah, So going back to SSI, how does SSI approach this problem of digital identities? So as when solving any problem, it's the easiest approach is to look at some other place where a similar problem is being solved. So how are we solving this in real life, like offline? How have we survived so far? And offline in the real world, we have something called credentials. So this is a very well understood system. It's decentralized, and credentials are used to signal some subjective attribute about yourself. Well, to prove some subjective attribute about yourself. So, for example, a government ID document, you can prove with it that you are a resident of some country. With a driving license, you can prove that you can drive a car. With employee badges, you prove that you are an employee of some company. Same with membership badges, you can prove that you belong to some club. Certificates can prove a whole broad range of things, from, let's say, that you successfully completed some AWS course or some cybersecurity training, or let's say you won a bike race 10 years ago. Diplomas can prove that you attained some level of knowledge in some institution. So this is a really broad concept, so that's used everywhere in our daily life. And but looking at it more, fundamentally, how does this work is because of something called the trust triangle. And in the trust triangle, basically, there are three components to it, basically. There is the issuer, who is somebody who basically issues the credential to you. Then there is the holder, is the person who holds the credential. And the verifier is somebody who basically consumes the information contained within this credential. And the reason why the police officer who stops me and checks my driving license, why he can infer that I really can drive this vehicle, is because he trusts that the issuer, which is the government of Slovenia, issued me this driving license only because I passed sufficient tests and I did sufficient things to prove that I'm a safe participant in traffic, right? So this is kind of the essential structure that's then used by SSI. So to look at, for example, how SSI works, let's look at a famous example that's used within SSI. So I'll introduce some terminology as well with this example. So it's called Alice and Faber. So Alice is a former student of Faber College and is offered from Faber a verifiable credential. So a verifiable credential is basically what we call the digital analog to the normal credential. And she can use then this credential to basically prove to anyone that her accomplishments in this university. Alice then goes to Acme Corporation and she presents this credential to them to get a job. And Acme Corporation, they know that they can trust this credential because they can cryptographically verify that it was really issued by the Faber University. So now that Alice has a job at this corporation, she gets a new credential which represents her employment status. So with this new credential, she can then go to the bank and once again prove that she now has a job. And the bank, as the corporation did before, they can verify that this is indeed a valid credential, and they can issue her a loan based on this. So it's really a trivial example, but what are kind of some of I guess more entertaining examples that I really like is, for example, entering a bar. This might be more relevant to outside. This might be more relevant in the States, where each time you enter a bar, they basically have to check your ID so that you're over 21. But as you're doing so, you're actually, you're exposing a lot of information about yourself. So in order to prove this one, Boolean value, whether you're over 21 or not, you have to basically expose your whole some legal document, right? So the bouncer can see all information about you. What's your name, when you were born, where are you from? There's a clear overexposure compared to the information that's needed to establish, that you're over 21. So why verifiable credentials are really interesting in this regard is because the technology behind it can offer a really novel ways to dealing to this problem. So, for example, this bouncer example, in order for him to establish that you are over 21, he basically needs to do three things. He needs to first figure out, is this document fake that you gave him? So is it really issued by the United States government? Then he needs to figure out, is it really you on this picture? So does this document really belong to you? And the third thing is actually, is your birthday over 21 years ago? So, and credentials actually aim to have those things of authenticity and ownership baked into them. So one thing that's, so for example, with a verifiable credential, you can just prove with minimum information that you really are the owner of the credential. The credential is really issued by the United States government and that you are over 21. And you can do that without revealing any other information. So you don't have to reveal your name, you don't have to reveal your picture, you don't even have to reveal your birthday technically. And this is, I'll go more in detail about how this is done then when we'll get to the verifiable credentials, but using this, using cryptography, we can really nail down how as little possible information that has to be shared in contexts like this. Another interesting example is, and extremely relevant today, is vaccination credentials. So especially in the States where it's basically just a piece of paper, which can really easily be forged. But even in Slovenia recently, we had this problem where when you scanned our digital certificate, there was for a time no personal information was shown, so there was really no mechanism to establish whether somebody presenting you this certificate is really the owner of this certificate. So verifiable credentials have this component within them that binds the holder of the credential to its ownership. So you can prove that. You can be assured that somebody presenting you a credential is really the owner of that credential, and it's not some person that somehow stumbled upon this piece of data and is now sharing it with you. So yeah, but yeah, basically with these models, self-sovereign identity hopes to create a system where digital identity is not just something that's scattered around and you interface with it and are at mercy of other corporations and institutions, but rather your identity is a centerpiece in this story and it's controlled by you and only you, and you choose to explicitly give, let's say, permission to other services to gain access to parts of your identity, for example, personal information. So this was kind of high level, but let's look at how actually this works. So if we look at if we return back to the Faber example, so here we have three components, three actors in this system. Same as in the triangle, you have the issuer, which issues a credential, you have the holder, which holds it, and a verifier that consumes this credential. It doesn't consume the credential directly; it consumes a presentation of this credential. And in the background, it's using some support systems, mainly it needs to use for let's say the centralized identifiers, and I think we can move to the next slide. Yeah, for the centralized identifiers, it needs to use some ledger to store the information. But first, what are decentralized identifiers? So decentralized identifiers are one of three components that are used in SSI, and on a high level, they are just an identifier that points to a record, and this record can really be anything. The whole point is that this identifier is universal and can be resolved basically by anyone. So how exactly does this look? So if we look at this URL here, so this is called a DID, decentralized identifier, and it's composed out of three parts. So first we have the prefix for this DID document, so for this DID URL. And so this just identifies that this URL is this exact thing. The next component is called a DID method. So a DID method essentially tells somebody resolving this URL how to resolve it. So there are many DID methods. For example, Vidcon is one DID method, Ethereum. There are some other blockchains that are more specialized for identity, like Hyperledger Indy. There is one called Ontology, but it basically just dictates. So the DID method just dictates what's the process of resolving an identifier, and the last piece of it is actually the identifier itself. So using all those three, you can then, using some, for example, universal resolver, you can end up with this DID record. So this DID record can technically have anything according to the specification, but what it's mostly used for is for decentralized public key infrastructure. So when issuing verifiable credentials, they contain a signature which is used to assert of its validity, and that the key to verify this signature is actually stored within this DID. So DIDs themselves are, they're looking at it like from the architectural perspective, they're the most critical component of the SSI infrastructure because they represent the root of trust in this system. So anyone verifying that the issuer really did issue some credential needs to resolve the keys that were used to, the keys that can be used to verify those signatures, which are controlled, which are basically located on this decentralized identifier network. And the authenticity of this network then is really important. Like the institutions or anyone using this network needs it to be extremely secure. Otherwise, it cannot really be trusted. So the next component that I already mentioned before are verifiable credentials. So this is a W3C standard. W3C standard. I think it was pretty recently that it was actually standardized, but it's been kind of in the works for some time now. But yeah, just looking at this example, this is just a wrapper of some attributes that are in regards to some subject, along with some proof that these are authentic. So it's a pretty simple model. It's basically some data that's signed. And within this signature, there are links to how to verify this data, which usually point to some DID record, let's say, of some university. So in this example, you can see that this, for example, is a Bachelor's of Art degree, so a university diploma, and this is basically being held by the holder and is then transformed into something called a verifiable presentation and shared with verifiers that are interested in this information. So earlier I mentioned that I think that this has a much broader social impact. And the reason why is because specifically this format of verifiable credentials is a really efficient way to encode some trust. And I'm not really sure what this would look like in practice, but just thinking kind of high level, trust is a really important component, like of our everyday life, of decisions of any decision-making process. And if we enable people, and if we have tools to really efficiently create this trust and securely share it between anyone, I think this can be extremely powerful. So we have this. I have this idea for an ad within Global ID, which is basically it's using for promoting digital verifiable credentials, and it's basically you get an email from a Nigerian prince, but he actually submits a credential with the email, and you can be assured that it's really the Nigerian prince, so you get to keep that inheritance. But yeah. So moving on, like what are some verifiable credentials have some really kind of magical properties, and those are done through basically some cryptographic tools. One is zero knowledge proofs, and the other one is called holder binding. So this is done through various signature schemes. So some flavors of verifiable credentials are really basic in a way, where they do not provide this functionality, but some are, some really novel ones are really sophisticated, and they do. But basically what holder binding does is it enables a holder to prove that he's really the owner of some credentials. So this is what I was talking about earlier, where there is always a problem of thinking, did this person, let's say, steal this document? Is this document legitimate? So with holder binding, you're basically addressing this exact issue. But zero knowledge proofs, on the other hand, are more around the attributes that are being that you're proving. So for example, with zero knowledge proofs, you can essentially prove that, for example, you are over 18, as in the earlier bar example. But that doesn't mean that you send them your birthday and they check whether it's more than 18 years ago. You can essentially, with zero knowledge proofs, you can essentially produce a proof that proves only that you're over 18 without revealing why this is true. It doesn't reveal your actual age, and this can be extremely powerful, extremely flexible. You can prove all sorts of things with this. You can prove that you have enough money in your bank account, you have enough that you pass, let's say, some background check, that you have a valid driver's license, that you've had a valid driver's license for, I don't know, more than 5 years. You can prove that you really are a Nigerian prince. You can prove, I hope in the future, you can prove that you're human as well. So I hope that we can do proof of humanity essentially with verifiable credentials. And the issue of proving whether you're a bot or not is not, data mining for machine learning anymore, but rather just presenting some proof cryptographic that can be trusted, that you're actually human. So the third component of kind of the SSI stack is Vidcon. So this is essentially a communication protocol that establishes, it provides basically three things. One is interoperability. Why is this important? For the same reason why it's important that your browser and all the other websites can communicate through HTTP. So there needs to be, a common language that's spoken between all these different agents, as Vidcon brands them, so that all these different agents speak the same protocol, and at the same time that they can guarantee privacy in a way that your data is private. So your data is secure and encrypted. And another important component is that your data is uncorrelatable. So that what that means is that, for example, if I interact with my bank and my employer, if my employer and my bank then collude for some reason, they cannot figure out that they were talking to me. So when talking to them, I'm a completely different person. And yeah, the third part is kind of security, which is essentially guaranteeing that all the messages that are sent between these agents are end-to-end encrypted and only for the recipient of those. So here is actually where Python comes in. So the most popular Vidcon implementation is done in the Hyperledger Aries ACAPI cloud agent. So that's kind of where the most activity is happening in this regard. So shout out to Python, I guess. But yeah, so who is involved in this space? Like what's exactly, how much of this is being used, how much is just academic? So there are certain things that are certainly being developed right now, which are, specifically, let's say the signature schemes, which are using zero knowledge proofs. Those are still in active development. There's lots of community activity around it. So, there is much work to be done, but at the same time, some fundamentals are pretty established. So this is mainly developed kind of by, it's an open source project, but there are kind of three parties that are really involved here, which there's a huge overlap between them as well. But one is the Decentralized Identity Foundation. The other one is the W3C working groups and the Hyperledger community. But there's also many providers of this technology on the kind of infrastructure level. So the kind of one major party that was really driving this in the past and is still driving is the Sovereign and Indicia foundations. But there's also like big tech corporations that have been really getting ground on here. And one is certainly Microsoft. They've been really cutting edge in this regard and are providing lots of infrastructure within Azure. So they're basically providing their own DID methods. They're providing APIs for issuing verifiable credentials. They don't do any fancy cryptography. They just provide whatever they have in their key vault. But it's still, very interesting that they are a player in this space. Another one which I find really interesting is the Baidu cloud. So Baidu is kind of Chinese Google, so a really huge company. And funnily enough, the way they named their DID method was DID-CCP. So it's kind of fun, at least to me. But who then uses this technology? So I think that the most significant consumer of this technology is the British Columbia government in Canada. So they've issued, through Sovereign, they've issued around, this number is probably wrong, but I think they issued around 500,000 credentials, something like that, or 50,000, some number in the thousands regardless. But for example, in British Columbia, you can, if you're a lawyer, you basically use verifiable credentials to gain access to court records. So this is being used in basically in legal systems, which is usually a great sign because usually governments are the last institutions to really kind of move on some technology. So there's lots of conversations around vaccine credentials as well. So there are a couple of working groups in W3C which focus specifically on the vaccine use cases. There's been another use cases that I've heard of but haven't seen much, and it's using credentials in education systems in Africa, in Nigeria. So I think this was done through Atala Prism, which is a Cardano project. And but yeah, so that's also one very interesting use case. So how are we using this at Global ID? So at Global ID, we basically provide an SSI wallet, so to every identity in our system. So every identity can hold credentials and can exchange those credentials with anyone who's interested, and receive those credentials from anyone that's providing them. So we're using all three components of the SSI stack. So we aim to be interoperable and to provide a neat UI to anyone using this technology. So we're at the same time we're actually providing an issuing platform for, let's say, institutions that can integrate through APIs to issue these credentials, and at the same time a more UI friendly experience for, let's say, smaller groups, where they can they can issue, let's say, a certificate that somebody participated in some race without having to program Python potentially to do so. So yeah, I mean, this is still, it's not really exactly in production, but hopefully it will be soon enough. So yeah, this was it. Hope it was interesting for you.
Thank you, Jakob. Yes, that was very interesting. I'm really glad we got to hear something, so cutting edge, so that we can be kind of ahead of the curve. It doesn't really happen that often that we get to, talk about technologies that are kind of developing. And yeah, I think it was pretty clear and understandable for a broader audience. So I like that as well.
Right, thanks. Yeah, that's always kind of an issue, because I don't know how much terminology or something I'm actually using. So it's hard to gauge how understandable you are when explaining.
Yeah, I think this was kind of, it was both. It was, yeah, you're getting the thumbs up from Kaya, which is always the goal for me as well. But we do something that a lot of different people from different backgrounds can enjoy and understand. So we have one question. Yura, should I just read it, or do you want to speak? I'll just read it.
I can speak.
You can speak? Yeah, I thought it could be better because you could explain it better. The floor is yours, Yura.
Okay, so you had an example before where you said, like, you can ask, if the license exists for 5 years.
Mm-hmm.
And that sounds like a function, that's like something that could be a dynamic ask, like 3 years, 5 years. Where does this check happen? Does it need to be defined prior? And how do you prevent, denial of service attacks with these kind of checks?
Yeah, I mean, so this is done through, so basically this is done through zero knowledge proofs. So there is so for example, ZK Snarks, bulletproofs, I don't know how much you're aware of them, but basically these are zero knowledge proofs for arbitrary circuits. What that means is that you can take a program, let's say a program that says, is this value, let's say, smaller than 5, and you can basically do any function check you want. But basically you then transform this, you take this program, you transform it into a circuit, and then you can produce a proof, a cryptographic proof that this circuit was executed correctly, and basically it was executed correctly with some input data that's private. So what that essentially enables you to do is that I can say to you, hey, run this program on your phone, and that program will check, is this data that you're giving me, so is this data, cryptographically secure? So is this data signed? Is this data, does this data really belong to this person? And does this data essentially conform to this arbitrary criteria that you specified within this program? and you can just give me back some cryptographic proof. I can check on it. I can be sure that this program was executed correctly without me having to, rerun it myself or check that the inputs were correct. So it sounds like black magic, but it's pretty, it's pretty interesting, at least to me.
It makes sense. Thanks.